Hey folks, Miss Bish here, and we are going to be doing a guided tutorial through a video presentation for our discussion of proportions. So what you're going to do is follow along in the self-guided notes that you've received, work out the examples as I do them, and this will give you the opportunity to pause or rewind if you need to hear something repeated. And as always, if you have questions, just ask. So let's get started. First, what I have here are 4 problems involving just arithmetic. Notice that this is addition, subtraction, multiplication, division. The fractions are all the same, but the operation is going to be different. There's a reason why I'm revisiting this. So with addition, what's the method that we use? Well, we use getting common denominators. You cannot add fractions unless they are in a common form. So you look at 8 and 4 and you think about what is the least common multiple between 8 and 4, and the least common multiple will be 24. So I know I want my new denominators to both be 24. So what am I going to do to this first fraction in order to get that denominator to become 24? That is to multiply by 6. So I'm going to multiply top and bottom by 6. So my new fraction is 6/24. Let's take a look at the second fraction. How do I get from 8 to 24? Well, I do that by multiplying by 3. So I have to multiply the numerator by 3. 1 times 3 is 3, so I have my new numerator. Now I'm going to add them. 6/24 plus 3/24 gives me 9/24. And then you ask yourself if you can reduce, and I can because they're both divisible by 3. So my final answer would be 3/8. Okay, so how do we add fractions? Getting a common denominator. Subtracting is a similar method because we also need common denominators. Denominators. Okay, so to save myself from some work, I know I'm using the same fractions I did over here. I just went through how to get them common denominators, so I'm just going to recycle that. 6/24. This time I'm subtracting 3/24. 6/24, taking away 3/24 gives me 3/24. And this can also be reduced. Hold on, let me get my little screen out of the way here. Give me a second. Okay. So 6/24 minus 3/24 was 3/24. I can reduce that by dividing by 3. And that gives me 1/8. Okay, now multiplying. How do we multiply? The method is that you multiply straight across. We don't have to worry about common denominators. We just multiply numerator times numerator, which would be 1, denominator times denominator, which would be 32, and this one is already simplified. Dividing, I want to keep, change, flip. Dividing of fractions is the same thing as multiplying by the reciprocal. Then I treat it the same as multiplication and go straight across. 1 times 8 is 8. 4 times 1 is 4. Hold on, my screen is in the way again. Let me move it. 8 divided by 4 then is 2. Okay. You may be wondering, why did she just spend all this time going through this? We've already covered this. Well, there's a reason. And the reason is, though they may look the same, these are expressions. This is an equation, and I don't want you to start confusing the two. So, how do we solve a proportion? A proportion is an equation where you're comparing fractions. So we want the fractional value that's on the right side to match the fractional value that's here. Okay? How do we do that? Well, let's talk about it. Currently, x is being divided by 4. And the best way of getting rid of that 4 then would be to multiply both sides by 4. Hey, guess what? It is a good thing that we just reviewed multiplying fractions, because here we are with a fraction. I just put that over kind of a dashed 1. That's my way, remember, of showing an imaginary 1. I can multiply across the top, which gives me 4. Whoops, let me change how I'm putting this. Multiply across the top, which gives me 4. Multiply across the bottom, which gives me 8. And reducing that would be 1/2. You may be asking yourself, Miss Bish, why don't we just cross multiply? And here's what I want you to know. Cross multiplying is just a fancy way of doing this same process. I don't want you to start cross multiplying on every problem that involves fractions, because we can't. We can only do it on proportions. So here's what I'm going to do. I'm going to clear this, and now I'm going to do it by what you know as cross multiplying. Cross multiplying 8 and x gives me 8x. Cross multiplying 4 times 1 gives me 4. Now what? Divide by 8. And hopefully you've worked both of these out and you have them side by side. I was out of room, I had to erase it. But working these both out side by side, you see that we get the same thing, and ultimately it was the exact same problem. What we call it was just something different. Okay, but the math is that we're still working backwards. We're undoing what's happening in the equation. So let's do a few more. On to the next page, example B. So now that we've revisited this, I'm going to solve by cross multiplying. Personally, I always start on the side that has x, since that's what this is all about. What value of x is going to make this true? So what's x getting multiplied with? 13. So I'm going to multiply 13 times x to get 13x equals, because it's a proportion. Go to the other side, 10 times 5 gives me 50. How do I get x by itself? Divide. Forgive me, this is a little sloppy for my liking, but we're going to go with it. And as you know, we can just express this as 50/13. Okay, example B. Now, I know sometimes these negatives get confusing, okay? So, this is a negative value, and in order to keep this a negative value, we need to use that negative just once. Just once. So in your mind, I want you to place that negative either with the 2 or with the 21. Personally, I place it with the numerator, because as you read this number, you call it -2 21sts, or -2 over 21. So in my mind, the negative is with the 2. Okay, technically it's with either one, just as long as you use it once. The reason I'm saying that is as we cross multiply, you want to use that negative just once. So here we go. X times 21 is 21x. Oops, that looks kind of funny. Hold on. 21x. And then cross multiply going the other direction. -2 times 8 is -16. We want x by itself. It's not. So let's divide 21 to get x by itself. And -16 divided by 21. Can that be simplified? Let's see. 4, 2, nope. So that's it. -16 divided by 21. All right. Hopefully you're doing okay so far. You're not there for me to check on you. But let's keep going. Okay, D. So I placed x in a different location, and if you treat this the same way that I'm suggesting, you shouldn't have any problems, because put your eyes where x is. That's what this is all about. What value makes this true? Well, let's multiply x by 5. What's the result? 5x. Let's cross multiply the other way. 10 times 11 is 110. Let's divide by 5. And what does that give me? x divided by 5, 22. Okay, hopefully y'all are doing okay. If at this point you have any questions or you need to revisit a problem, you may rewind. Or if you're in the classroom as you're watching this, just come ask me. Okay, hopefully this feels somewhat familiar as you have seen this prior to algebra. Now, here is where it's new. How do we treat it when we don't have x by itself in that fraction, but it's being evaluated with another term? What do? We're still going to cross multiply. Here's how you handle it, folks. This x plus 1 has to stay together as a unit. So this x plus 1 is getting multiplied times 4. How do I express that? Well, we have this fantastic way of keeping terms together in math, and that's with parentheses. So I'm going to keep that x plus 1 together as a group in parentheses, and since I'm multiplying it times 4, I'm going to place that 4 in front. Why am I placing that 4 in front? Well, hopefully you see why, because we are going to distribute. And we're usually more comfortable distributing with that number placed in front than we are if I would have put it here. Would have been right if I put it there. But I'm going to try to make your lives easier, not harder. Okay, let's distribute. 4 times x, 4 times 1. The result of 4 times x is 4x. The result of 4 times 1 is 4, so I'm going to bring down a plus 4, equals 30. Now you're home free. It's a two-step equation. Subtract 4 from both sides. What am I left with? 4x equals 26. Divide by 4. This isn't going to work out beautifully to an even integer. That's okay. Divide by 2, and I get 13 halves. Okay, so what did we just do? We had to keep the x and 1 together with a set of parentheses so that when it was multiplied with the 4 got distributed to the x and the 1. Are we okay? Let me know if you're not. All right, now what I would like you to do, oh, we have one more example, sorry. So here I go again. X is hanging out with a plus 1, so that's a group I want to keep together. What is that group being multiplied by? 1. This is interesting. Well, what happens when we multiply anything times 1? Turns out it's going to be just that. Okay? Distributing 1, same thing. What's going on the other side? A 6. So this ends up being not too bad. A little baby one-step equation. Subtract 1 from both sides, and we are left with x equals 5. Now, don't forget, you can always plug this in and check it. Well, Miss Bish, I'm not quite sure how. Well, let's do it. Let me plug that 5 in, and let's look at what this proportion would be. Well, on the left side, it becomes 3/6. On the right side, it becomes 1/2. Are those fractions the same value? Are they the same number? Absolutely. Now, here's what I'd like you to do. I keep thinking I don't have any more examples, and I forget that I have more. So let's keep going. Okay, again, x is hanging out with something else. It's a group. So I'm going to keep it together as a group. What's x minus 8 get multiplied by? 4. Let's put the 4 in front to make it easy on ourselves. Let's cross multiply again. X plus 3 has to stay together as a group, and the 5 it's getting multiplied by is going to go in front. We have to distribute twice here. That's okay. We've been doing that all the time lately. We're getting so much better at it. All right, here we go. 4 times x is 4x. 4 times -8 is -32. So I'm going to bring that down as a -32. Let's distribute again. 5 times x, 5 times 3. 5 times x is 5x. 5 times 3 is 15. So I'm going to bring that down as a plus 15 since it was positive. Then we get stuck because we have our variable on both sides of the equal sign, and it's hard to isolate it when it's in two places. So let's get rid of one of them. Doesn't matter. I'm going to pick the 4x. It's going to make my math work out nice. That's the only reason. So since it was positive, I'm subtracting 4x from both sides. Let's see what's left over. Well, 4x minus 4x is 0. Gone. We wanted that to happen. Negative 32 left over on the left side. On the right side, I lined up my like terms. 5x minus 4x is 1x. I still have the plus 15. One more step and I'm there. Subtract 15 from both sides. And negative 32 minus 15, which is adding a negative 32 and a negative 15, is negative 47 equals x, or x equals negative 47. Okay. Now, here is what you're going to do. You are going to try these 5 problems using the same methods that I did in the first few examples. Pause the video, work through the 5 problems. When you're done, unpause it, and I'm going to have the solutions ready for you. Okay, do that now. Okay, so hopefully you finished working them out and you're feeling pretty good. Here are the solutions. Number 1 is x equals negative 18. Number 2 is m equals 4.2. Ooh, sorry, I don't have that as a fraction. Let me get that real quick. 21/5. Okay, number 3, you will have 16.6 repeating, or 50/3. Number 4, since it's one of the newer ones, I'm going to work that one out. So w plus 3 is the group that's kept together, and that is getting multiplied by 2, so I'm going to put the 2 in front, equals. Cross multiply the other direction. It's a little easier going the other way because I just have 4 times w, which is 4w. Now I'm going to distribute. 2 times w, 2 times 3. The result of 2 times w is 2w. The result of 2 times 3 is 6, so I bring it down as a plus 6 since it was positive. And I still have the 4w on the other side. I'm stuck again. I have w in 2 different places on each side of the equation. That's a problem. Get rid of one. Now, here, it's going to be a better decision to get rid of the 2w than the 4w. Why? Because I want to leave something over here on the right side. If I got rid of the 4w, I would leave a 0. It would leave nothing. I'd have to ultimately move something back. Just causing me more work. Trust me when I say I try to make things easier on you to help you. Okay, so I'm here. 6 equals 2w. We're home free. I'm kind of running out of room, so divide by 2. Divide by 2. w's 3. Okay, number 5. My eyes go here because that's where the group is. So I'm going to start with that. 3b plus 4 sticks together as a group. What's it get multiplied by? Go across. The 2. Putting the 2 in front to help me distribute. Now I'm going to the other group, b minus 4. What's that getting multiplied by? Go across. It's getting multiplied by the 3. Again, I put the 3 in front to distribute. Okay. Here I go distributing the 2. That gives me 6b plus 4. Over here, forgive my pen, got a little sloppy. Distributing the 3, and that gives me 3b minus 12. We have b's on both sides, that's a problem. Get rid of one. I'm going to pick the 3 to get rid of. Since it's positive, I'm subtracting 3b from both sides. All right, let's see what's left over. 6b minus 3b is 3b. Bring down the plus 4. On this side, this is gone, leaving a negative 12. Okay, from here, it's a two-step equation, and I know from class you are really comfortable with those. So I'm going to go ahead and jump to the answer from here since I'm out of room, unfortunately. And you get negative 6.6 repeating, or that is a negative 20/3. All right, hopefully you're feeling pretty good about this at this point. I'm going to do one more thing. Where do these proportions come from? Well, they come from comparing different values, okay? Helping us to compare different pieces of information to find unknown values. So let's look at a word problem. Example H. A band went to a recording studio and recorded 4 songs in 3 hours. I'm going to write that down. 4 songs in 3 hours. That goes together. It came in the same sentence. What are we comparing it to? Well, how long would it take the band to record 9 songs? So, here's the thing about writing proportions from word problems. There are lots of ways you can do it. As long as you're consistent, you'll get it right. What do I mean? Well, on this side, I'm comparing songs to hours. So on the right side, I also have to compare songs to hours in the same order. Since hours is what I'm trying to find, that's going to be my unknown value. So I just used our ever so popular x. So basically, the proportion we're solving is 4/3 equals 9/x. I just took the words out to make it look a little less scary for you. So here we go, cross multiply. 4 times x is 4x. 9 times 3 is 27. Divide by 4. And x is, oh, that fraction doesn't reduce. Let's see, it's the end of the day. Forgive me, I'm using my calculator. 6.75. Not trusting my head right now really well. Okay. Now, here's what you're going to do. You are going to pick up the assignment 1 through 15, and it is setting up the word problems. So you're going to read it and set them up. Remember, just be consistent. Once you get them set up, you're going to work them out. And when you're done, just hang on to it. If you have time, once you're done with the classwork, here's the homework. Okay. Good luck, everybody.